I wanted to thank everyone for coming tonight. This is for state revolving funds. We're talking about a couple projects that we're proposing to submit to state revolving funds. It's a program through the state to get loans and then some grant funding. So we'll start with the CIPP project, and John Goyne will talk about that a little bit here. So John, you want to come up? Thank you very much.
Hello, my name is John Goen. I'm an engineer here in water sewer, and I was the project manager on a CIPP lining project that we just finished up last night. So I've been here at the city for almost 2 years, and I'm part of Adam's team in engineering, so let me start up the. So CIPP is a cured in place pipe, and I have some examples here we could look at later, or be happy to discuss or field questions. So many of our older lines in the city are clay, and I got an example of this in this photo right here, and clay tends to crack easily or settle over time and crack as this shows. So with these cracks, you can get groundwater or rainwater into them, and we'll be having to treat that water unnecessarily. Also, roots can find a way in and clog up the line and cause backups. So water that we don't need to treat obviously costs more money to treat at the plant, and roots have their own issues of clogs and having maintenance issues that our crews have to go fix. So there's a few ways to address this that we considered, alternatives to maintain our older clay lines. And the first option is the do nothing option, which doesn't cost anything. And it doesn't really solve the problems. And it also increases our treatment costs due to all the cracks and root intrusions and extra maintenance we need to do. The second alternative we thought about was a full replacement with traditional means of excavation and replacing the line in place, and the impacts that has on the streets or wherever these sewer lines are. So trenching and digging up the lines and replacing is far more expensive, and it also has big impacts on anyone in the area, any neighbors, homes, businesses, if you're digging big trenches down the street or through properties or what have you. The other alternative that we looked at was ultraviolet cured lining, which is similar to the method we chose, which is thermal, but instead of using steam, use ultraviolet light to cause the liner to cure and harden inside the pipe. So in looking at and bidding this project to both ways, to do thermal or ultraviolet cured, we found it to be about 20% more expensive to do ultraviolet curing on these smaller diameters, which was the bulk of our project that we did just this last couple weeks. Similarly to thermal curing, it has minimal impacts. It's all done through manhole accesses, and it avoids trenching open the street. And so, it also solves the problem of cracked and failing lines. The option we went with was thermal curing. And so this is a photo of where it begins. It's this long roll that's typically like 400 feet, which is a standard length between manholes. So it'll be a long roll of a felt material that's stacked in the truck right here, and it's rolled through these wheels, so it's nice and flat, and then once it goes down into the manhole, it's pressurized with about 10 psi of air pressure, just to kind of make it unroll, like an inverted sock, if you will. So the air pressure kind of rolls it out down the pipeline and keeps it held up against the existing pipe, so it's you know, it's the same size basically as the host pipe. So the first step in the process is to kind of roll it out and pressurize it, and from manhole to manhole, typically. So this was a picture from last week of the steaming of the line. So you could see the liners sticking out of the manhole, and it's kind of closed off, so it maintains the steam inside there. And so the steam, which is about 150 degrees, turns the felt into more like a fiberglass or PVC, if you will. So it goes from a soft, malleable fabric to a nice, smooth, hard PVC, essentially, pipe. So it's kind of replacing it in kind without having to dig it up. The next step, once they get the liner in and cured, they steam it for about an hour at 150 degrees, and then they let it cool for a little while. And then this picture is the gentleman on their crew who's in a trailer and sends a camera and a robot down the pipe with a grinder and like a Dremel type tool, and it carves out holes in the liner where existing homes are connected, or businesses, so it's all done remotely. He drives the thing and finds the dimple where the existing pipe or the existing service line would come in, finds the hole, or he has measurements to go find it if it's not obvious. And he runs his little Dremel and pops a hole in it where the existing service was, and he also has a little grinder that can take out like lumps or veins, they call them. If it has like a small wrinkle, they can kind of just grind down and make smooth again. So it's all done remotely, and that's kind of the three major steps in installation and reinstatement of services. So this is just a picture of what it looks like to do it the traditional way of replacement is to, you could see digging a trench down the street and, you know, working around other services, water, gas, you know, fiber, all of it, and as well as the patching costs of replacing it. So the impacts of this are quite significant on anyone in the area or anyone near the area or coming through. It's far more expensive and time consuming, and it also you have to dig around every other known and unknown utility nearby. So the project we just did the last couple weeks, we did a little over 8,000 feet of lining, and the whole project cost $350,000, so less than $50 a foot. And so when the lining does about a block, manhole to manhole, say 400 feet, it took in situ form about 4 hours to set up, put traffic control up, push the liner in, steam it for an hour, run that robot in, cut out all the services, and they're out of there in the morning. So they would do 2 of those in a day typically. So like 800 to 1,000 feet a day for about $40,000. So I could only imagine if you were gonna dig down the street and replace the line, you wouldn't get very far for $350,000. Maybe you do 400 feet for that much money as opposed to 8,000 feet. So this is about 1/20th the time and about 1/20th of the cost versus the traditional means of trenching and installation and replacement. Virgil's probably far more knowledgeable about the loans and all, so I'm going to introduce Virgil. He's our finance, something like that.
Hello, everyone. Thank you for being here. I'm Virgil Pierce. I'm the rates and budget analyst for Greeley Water and Sewer. I've been with the city for about a year, and I've lived in Greeley for 5 years now. So we're here talking about the SRF program, so we wanted to have a slide where we kind of explain what the State Revolving Fund program is all about. The Colorado Water Pollution Control State Revolving Fund Loan Program is a state-managed program. The initial funding for the program comes from the federal government, and then the state loans out the money. As those loans are repaid back to the state, they then take that money that's been repaid and they loan it back out again. And so that's the revolving part of the revolving fund. What the program provides is low-interest loans for approved infrastructure projects. So in the case of water pollution control projects, these are projects that reduce the outflow of pollution into the state's groundwater and waterways. So the project that John has been talking about is a $3 million capital investment that we're spreading over the next 3 years, if we receive the funding. If we do not receive the funding, we'll just continue the project as an annual $350,000, $400,000 project. To fund this preferred alternative, we're anticipating no impact on rates. Of course, there's a cost to the project, but the project is correcting an increase in cost at our wastewater treatment facility. And so those two costs are kind of balancing each other out. So we're reducing what we're spending at wastewater treatment by spending this investment to rehab our collection lines. The SRF loan is going to borrow a portion of the funding for this project at a subsidized interest rate. And then we're going to use that to allow this project to be completed at a faster pace than we're currently planning. And so that's really the net benefit of this SRF program for this project. If we were to do the complete replacement alternative, we're talking about something, and as John said, there's a little bit of a question of how much it would cost, but it's something on the order of a $17 million project to do the kinds of rehab that we're talking about for our collection system. If we were to do that much capital investment for our sewer system, we're looking at a 14% rate increase for the customers on our wastewater system. So, John, would you like to talk about the environmental impacts, or should I do this? Okay. So for the environmental impacts, we're talking about a construction project that's occurring in the central area of the city. It's occurring in already disturbed soil, and as John mentioned, it's a project that we open one manhole and we push the pipeliner through to the next manhole. And so we're, in most cases, we're not opening the ground in between those manholes at all, unless something goes wrong and we need to get in. And so it's going to be mostly in the street, rehabbing and going through the existing wastewater collection manholes and pipes. And so we're predicting that the environmental impacts will be minimal, or we're anticipating that they will be minimal. SRF projects also have to go through a review from the State Historical Preservation Office, SHPO. That review is supposed to assess the impact the project might have to historically significant structures. We are not anticipating impacts to those structures because, again, this is a project that's just taking place within the existing wastewater collection system. And so, again, we're anticipating minimal or no impacts to historical structures in the city. That's it for our presentation. The whole point of this is to get feedback from the public and receive public input on the project. So we'd like to invite you to join us and share at the microphone if you do have some feedback for us or you'd like to comment on the project, or for that matter, the alternatives that we've presented to you. If you're more comfortable giving us written feedback, you could also fill out one of our comment cards and leave it with us. Thank you. Good. Yeah, so if there aren't comments, as John's saying, we have some displays up here of the material and the pipe and how the process works. So, welcome to come on up. Yes?
I submitted the
Okay.
question there.
Would you like to share it at the microphone?
Well, I was just curious. Probably is not, I probably don't need anyone. I don't allow now. Make sure it's great.
Okay. And city council, they always want me to tell my name, address, and serial number. Sounds like I'm in the military, you know. Edwin Wayne Grant. And I started out at 11th Avenue and 16th Street 70 years ago, went to 2221 10th Avenue, 1314 23rd Avenue Court. Now I'm at 2411 27th Avenue Place. My question's on your thing there. A lot of those pipes were put in long about the time the Weld County Courthouse was built, the early 1900s, or Kepner Hall at UNC, the 8th Avenue and 17th Street, or 9th Avenue and 9th Street. They used some lead stuff back there. The reason I know that is I worked at the Greeley Gas Company at 8th Street and 22nd Avenue from 78 to 80, and we had some of that stuff. I did some of their maps and stuff for them. That's now at Miss Energy. But as the old saying goes, get the lead out. I think they've had some problems with that in Michigan. Generally, the water comes in, it's pretty clear and pretty clean. Generally, you flush it down the toilet and ends up in the sewer department. It's not so clean, but it's not usually from lead, it's from various organic stuff in there. We noticed at the gas company, you can have lead pipes, used to be known as plumbum, that's because the Romans named it. Anyway, you can have steel pipes, they have iron in them. It used to be called ferrous or ferric, but they're alloyed with aluminum or molybdenum or something, and they're all heavy metals. Eventually, they end up somewhere at the sewer plant or something, and they have to be leached out or something. Otherwise, they're dumped in the river and sent on to Nebraska and Louisiana. We're already being sued by half of the states around the area. I think they settled a little bit of stuff with some of the surrounding states due to our 4 rivers, the Arkansas, the Colorado, the Platte, and the Rio Grande. Anyway, we're being sued by half of those states because we're not sending enough water down. Of course, we probably will have enough to send down this year, but some of the water we're going to be sending down the river is going to be more polluted than it has been in the past because of runoff from the cities, and it's going to pick up stuff as it goes over the streets and all that kind of thing. So the sewer plant is going to grow more and more expensive and more difficult to leach all that stuff out because it's going to be in the water. And they're going to have to clean it up, or we're going to end up with being sued by everybody. I think we're still being sued by California. I don't think they send enough Colorado River down to make California happy, but California, we used to call it the land of fruits and nuts. What are we going to do about all these lawsuits? These are going to be very, very, very expensive.
So I think one point I'll address to start with is the wastewater treatment plant doesn't treat any stormwater, so there's separate stormwater systems and sewer systems. So typically the sewer systems are picking up water directly from houses, sinks, toilets, different things like that. The infiltration here can be a little bit from the street, maybe if there's a leak in a manhole or possibly cracks. Typically that's groundwater, so it wouldn't have those pollutants. So there is very little that gets into the system that way. Generally, when it leaves our plant, it's significantly cleaner than general runoff water and we have significantly less pollutants that leave the plant. We're regulated on all of our discharges, and so we are discharging based on metals, nitrogen, phosphorus, TSS, total suspended solids, and a whole laundry list of other pollutants. So generally speaking, anything from the wastewater plant is not contributing. It's actually significantly improving water quality in the stream. Did that kind of address, or was there other things? So adjacent lawsuits would not be really affected by this project or our treatment plant.
So basically, you're just going to have the sewer plant at 1st Avenue and 8th Street out there. It'll just be kind of doing the duty for the flushing of the toilets and all that kind of stuff. It won't be trying to clean up anything from like the storm drains and all that kind of stuff.
So the question was, the wastewater plant won't be cleaning up stormwater and all that. That's correct. We get as little infiltration or other flows in as we can. This project would continue to reduce our flows. A fun fact is the flow into the wastewater treatment plant in 2022 actually matched the flow from 1971. So it peaked in 1995, and we've decreased every year since 1995. A lot of that is due to projects like this that reduce any of those water that seeps into the system. but typically it's not from storm, and if it is, it's small percentage. And so we try to minimize that. And so a significant benefit is these projects, and continuing to do them reduces our water that flows in that we have to treat, and then reduces the cost to the treatment plant.
When I was at the Greeley Gas Company 40 years ago, they had a little quip, steel pipes, steel money. Steel pipes being S-T-E-E-L and steel money, S-T-E-E-A-L. Well, the reason was the iron in there would rust a little bit, and then the methane going through the pipe would pick up that iron and send it into the furnace, you know, and stuff like that, so it would burn, go out into the atmosphere. Anyway, I wasn't there very long, but that was what they used to say. It was kind of equipped. So what they began to do was they take these steel pipes and line them with polyvinyl chloride, PVC stuff, and that seemed to really help that situation. But of course, that PVC pipe is a little flexible and, you know, kind of coiled up and all that kind of stuff. And as it freezes and thaws and stuff, it had its own set of problems.
Agreed. And so it's a similar process here. Most of our pipes are PVC. We do have some steel or ductile iron pipes. We tried not to do that anymore. They're historical ones. Some of our projects do line those materials so they don't block up over time due to the corrosion inside of the pipe. So it's a very similar process.
It's like a fender of a car, you know. They used to make cars out of steel, now they make them out of duct tape and tissue paper. But anyway, you know, you had a steel motor and like aluminum fenders and all that stuff. But if any place where there was iron, it would rust. You know, particularly in areas along the Atlantic seaboard, West Pacific seaboard. I mean, the cars have rusted this and rusted that. You know, that's just part of oxidation on the iron. So.
Agreed. Any other questions or comments tonight?
So, how permanent of a solution is this? What is the lifetime of the lining, and what does it look like for the future? Will we have to go back into these pipes further on and replace the whole thing, or can we reline?
So when we're doing these linings, it's due to a pipe that we don't anticipate enlarging. So if we were to enlarge any of these pipes, we would remove it and have to do a bigger pipe. We also would do pipe bursting if we needed to get bigger, but these lining of these type of projects are in locations where we don't anticipate increasing line sizes. The expected life on a pipe like this is probably 50 to another 100 years of extended life. Some of these VCP pipes are from 1908. We still have some of those in the ground, and up till probably the 1950s or 60s that were installed. And we do have about 115 miles of VCP or clay pipe.